Okay, guys. So, uh, yesterday we talked about how to label a right triangle and to get the sine, cosine, and tangent. So today we're gonna talk about more about right triangles and using trigonometry to find the different parts. So what you're gonna learn in this video is the trigonometric ratios, how to label the sides of a right triangle, and use trig ratios to solve problems. Here are your key vocabulary words. None of these words are new to you. So just go ahead and rewrite them in your book from the notes that we took in class, and then we'll go from there with your vocab. You will need decimals for this activity. So if you should be able to click on it on your PDF. If not, you can always Google decimals and do your thing from there. All right, so here's the problem. We're going to use our newfound knowledge about trig ratios. It says an airplane is at an altitude of 5,900 feet. The airplane descends at an angle of 3 degrees. About how far will the plane travel in the air until it reaches the ground? So this question, so remember when we approach word problems, the first thing we need to do is rephrase the question so we can make sure we're clear about what we need to solve for. It says about how far will the plane travel in the air until it reaches the ground. So I'm just going to paraphrase. How long in air until hit ground? Then you can paraphrase that any way you want to. The next step in our problem solving process is to draw a picture. Well, in this case, they gave us a picture, so we're lucky, and it wants us to solve for x. So it wants us to solve for, as this plane descends, how long will it be in the air? So it wants us to find this side. And if you notice, this triangle isn't complete on this side. So what I'm going to do is I'm going to redraw the triangle and I'm going to complete it myself. Okay, so the right angle goes right here, 3 degrees goes right here, the x goes right here, and this side is the same as this side right here. So I'm just going to put the 5,900 on this side, and now I have a complete picture. So my plane, my airplane, I can't draw y'all, but my airplane is going to make this trip right here as it descends, and this is the ground down here. So how long will it be in the air? How far will the plane travel in the air until it hits the ground? All right, so what we're going to do is use those skills that we used in class to label the sides of the triangle. So I'm going to put my finger on the angle. I'm going to put a mark on the angle, which is right here. And remember, when we're labeling a right triangle, go ahead, and the side across from the right angle is going to be our hypotenuse. And then from the angle they gave you, you're going to always be touching the hypotenuse and the adjacent. So this side right here is the adjacent. It's right next to the angle. So the side that's not the hypotenuse is always going to be the adjacent. And then the side you can't touch, which is way over here, is going to be the opposite. So this question is asking us to find the hypotenuse. Now, in order to find the hypotenuse, I'm going to look at the side that I'm looking for, which is the hypotenuse, and the side that I want to find, the side that I'm given, which is called the opposite. So we learned in class our trig ratios were SOHCAHTOA, and I'm going to tell you guys how I remembered it in high school, and I know I already told you in class. So the way I remember it was some old hood rat caught another hood rat taking off Adidas. So sine of theta equals opposite over hypotenuse, okay? And then cosine of theta equals adjacent over hypotenuse. And then tan of theta equals opposite over adjacent. And this is the ratios you can remember. There is a formula sheet for this, which I can give you, so you don't have to necessarily memorize it, but you're going to do so many of these till you will memorize it. So I've written down SOHCAHTOA, and I want to find my hypotenuse, and they gave me my opposite. So the trig function that has both opposite and hypotenuse in it would be sine. So I'm going to choose sine because it has both opposite and hypotenuse in it. So here, I'm going to write the trig function that I'm going to use. All right. And then my next job is to fill in all of the information. So theta is the angle, so I'm going to say sine of 3 equals the opposite, which is 59, 0, 0, over hypotenuse, which is x. Okay, I've written that down. Now I'm going to draw my little circle, and I'm going to say sine of 3 equals the opposite up here, which is going to be 5900 over HYP, which is x. And you're going to take your finger or your pencil and put a scratch through what you're looking for. And this should look like something you've seen in physical science. So to solve this, and y'all please do not skip steps, please write this stuff down. It's going to be x equals opposite over sine of 3. So you're going to say 5900 over sine of 3. Okay? 5900 over sine of 3. And now we're going to get our calculator, and we're going to do the math. So we're going to go to our calculator, and we're going to go to Desmos Scientific Calculator, or you can use your PDF, either one. And we're going to push our fraction key, and we're going to say we want our calculator to be in degree mode, so we're good on that. 5900, divided into sine of 3, and we get, let me see something. Yeah, we get the plane is going to be in the air this amount of time. Let's see, let me make sure I did that right. Yeah, I'm supposed to. Yep. Let me double check with my other calculator to make sure. And I'm just using more tools to make sure I have it right. Okay, let me check my mode. Oh, I'm in the wrong mode. This should be in degree mode. Yes, so let's go and try that again. Yep. So the plane is going to be in the air for 1,000, I think it's 112,733 point, what did it say, round to? We'll say we'll round to the nearest 100, 20 feet. So that's how far the plane will travel until it reaches the ground. It's going to travel that many feet until it reaches the ground. All right, and you will write your statement. And then we're finished. All right. So there's a couple more things I want to do for my even class since you're learning this from the video. Let me do an insert page. All right, so the different ways to set up the trig functions, because there are three. Oh, well, let's do this. So, toa. And remember, I told you a way you can remember it. Some old hood rat caught another hood rat taking off Adidas. And this is saying sine of theta equals opposite over hypotenuse. Cosine of theta equals adjacent over hypotenuse. And tan of theta equals opposite over adjacent. So here, when you do your circles to help you to solve, you always put the trig function right here, and then the opposite over the hypotenuse, and then you scratch out the one that you're looking for, and that will tell you how to solve it. So here you do cosine adjacent over hypotenuse, and then here you would use tan opposite over adjacent. So use these circles, and depending on wherever x is, you just scratch it out. If you scratch out the opposite, that means you're going to multiply whatever you have right here. If you scratch out the hypotenuse, that means you're going to divide whatever you have for this, like the other question here. Because I had to scratch out the x part, then that means I had to divide 59 over sine 3, and that's how I got what I needed. And that works the same for all of the trig functions. This should be familiar to you from science when you did density, if I'm recalling that right. Density equals, I forgot what density actually equals, but you should have done something like this in your science class. We're helping you to find density, mass, and volume. Okay, so go ahead and knock out this next problem. And remember, just label put your finger, label your hypotenuse first, put your finger on here, label the rest of the sides, and then use your trig functions from there, and use your circles to help you out. Do not skip any of the parts, guys, and this is for both of my classes. Do not skip any of these steps. Write them all down. They're important. Okay, see you guys later. Bye.